Hello everyone, this is KP the Math G here, and this is a nice snowy day today. Actually, it's not snowing, but the snow is on the ground and it's thick and no one can get out of the house. So we're just going to stay boxed in today. At least we are, at least I am, my wife and I, and we're just going to take time to do some calculus problems. What do you say? This is one of them here. It's a really nice problem. It has to do with, well, I can't think of it right now, but it'll probably come to me in just a moment. Related rates, that's what I was thinking of. See, I haven't taught in a while. I've been retired, so it takes me a moment or two to think of what I'm talking about. Related rates. This is a related rate problem. Just consider the curve, and I'm going to show you how you can figure this out. Okay? Consider the curve 6xy equals 2 plus y cubed. A particle is moving along the curve. At the instant when the particle is at the point 1/2 comma -2, its horizontal position is increasing at a rate of dx over dt equals 2/3 unit per second. What is the value of, and this is the rate of change of the vertical, all right, because it has y. X is going across, y is up and down, so this is a vertical rate of change at that instant. So we're looking for dy over dx, dt rather. Okay, so we need to look at this equation here, and we need to take a derivative, and we're doing this by related rates. And once again, the moment, the instant, when we see something like this, the instant, something like that, you see that word a lot in a related rate. It's going to be at a point. Sometimes most of the time it will be, and then you'll already have probably one of the related rates already given to you, so you just have to find the other. Alright, so we have a procedure to do that. I'm going to flip this over. Ooh. Excuse me. Alright, there we go. Now, let's take a look at this. Now, we had 6xy equals 2 plus y cubed. At the point 1/2 comma -2, dx over dt is 2/3 units per second. Okay, so we're going to find dy over dt in units per second. So let's start with the problem itself. This is 6x. Now, I think I'm just going to go ahead and take the derivative since I'm low on space here. Alright, so the first times the derivative of the second. The derivative of y is just 1, but now when you put it 1, when you write it as 1, you just don't write a 1 there. You just simply put, you can put 1 times if you want to, 1 times dy. You always, when you are dealing with y or x, either one, you are going to put that on the end. That's how you do those related rates. So it's the first times the derivative of the second. I'm just going to erase that 1 right there and just leave it like that. So plus the second, which is y, times the derivative of the first, which the derivative of 6x is 6 rather. So 6 times what? dx over dt. So anytime you are taking the derivative of the y, you're going to stick dy over dt there. If you're taking the derivative of the x, you're going to stick dx over dt there. Okay. Now we have that side there, and it's equal to, let's might as well just put it over here, equal to derivative of a constant is 0 plus y cubed. So again, 3y squared times, we ought to know how to do this by now, especially since we've been, a lot of y'all are been in here for a while and you did derivatives. Well, that's probably second to limit. So after limit, you did derivatives. So all sorts of derivatives at that, didn't you? You should be able to do this almost blindfolded. But 3, take away 1, there you go right there. Alright, so now dy, tack that on, don't forget that. And of course, that's what it's equal to. Okay? Now, let's rewrite it here. Maybe we have a little more room here. Let's see. Alright, so we don't really have to solve for dy over dt. We are going to do that, but we're not solving for it here. Now we can start plugging in numbers. This is x, this is y, right? This is dx over dt right here, so we have that. Alright, so we have that. Let's start plugging in numbers now. 6 times x, which is 1/2. Well, we know what 1/2 of 6 is, don't we? Alright. Now times, let's just follow everything through, dy over dt. That's what we're looking for, right? Alright, now plus y, but we know what y is, it's -2. So -2 times 6 times dx over dt, which we know that answer too, by the way. Ooh, by the way. That is given to be 2/3 times 2/3. Alright? Alright, so we know that. Alright, now that's equal to 3y squared, which is, we know what y is. Y squared. Okay, so y squared is -2 squared. -2 squared. And we're still looking for dy over dt, right? Okay, that we do not know. Now a little arithmetic, so let's do it. 1/2 of 6 is 3 dy over dt plus, okay, so -12, if you want to do this, -12 times 2, 12 times 2 is 24, 24 over 3 is 8, so -8, correct? I mean, if I wanted to, I could mark out 1, 2, 2 times 2 is 4, times 2 is 8, so -8, there we go, equals. Alright, now remember, this don't make the mistake that Algebra 1 students make. Even some Algebra 2 students make this. And we'll multiply this first, and you know that. -2 squared is 4. 3 times 4 is 12. So 12 dy over dt. Now we're close, aren't we? Let's take this over here now. Okay. -3 dy over dt. Just subtracting that on both sides. -3 dy over dt. Alright. And we get -8 is equal to 9 dy over dt. Alright. That's what I've got so far. And for whatever reason, I have missed it. Okay, so let me see. And you know, I happened to notice that answer was positive when I first did it. Well, let's go back over. Let's see. I think we did everything right here. Well, let's see here. 6x dy over dt plus y times 6 dx over dt equals 0 plus 3y squared dy over dt. That's good. 6 times 1/2. Alright. Everything looks pretty good so far that I see. This 12 is a 12 negative. Why do I have the 3 negative here? And it should not be. Okay. Yeah, I have the 3 negative here. I don't know why I have it negative. So far what I see here is this is good. So dy over dt is negative 8 over 9. And that's going to be in units, or negative 8/9 of a unit per second. Just going to abbreviate that. I don't know why on my paper here I have negative 3, and it should not be 3. This is plus here, so this plus here and the 3 in front of the y. I don't get it. So 3y squared dy over, so that's plus here. This is correct. Alright, right here. So negative 8 over 9 unit per second. Now this is, what is this doing? Increasing or decreasing? What is the vertical, actually the vertical rate of, if it were to ask, what is the vertical rate doing? It's not increasing, it's decreasing at a unit of 8/9 unit per second. It's decreasing because the value is negative. We saw that this is increasing because this value is positive. Okay, so this is decreasing, and I don't know why. I'm doing stuff in my 65th year of my life. I don't know. I'm doing stuff that I shouldn't be doing. But obviously this is a plus here, so this should be plus here. So again, right here. Alright, that's it. That's all I have for this one. Again, I apologize for the error that I made. I thought I made an error because I had it differently over here. And needless to say, that is not to be negative. And why I put a negative there, I do not know. I made this 3 negative. It should not have been. Okay, well that's it then. Again, it's a related rate. And anytime you see some words, let's just kind of review just a little bit. Excuse me while I flip this over. Anytime you see that a particle is moving, usually when we see the word the instant when, okay, and usually you're going to have a point, you're already going to have a rate here. Just know that you're going to have to find the other. Let me give you, while we are at it, let me give you a little illustration too. You have seen the ladder on the wall, haven't you? Okay. We're going to erase all of this, but okay, now let me see here. Here's a wall here. Okay. Alright, that's a wall. Here's a flat ground. It's going to always be flat. It's always going to be at a right angle right here in these cases. And there's a ladder up here against the wall, and the ladder slides out. So this distance when it goes out this way, this is increasing because this is actually going further and further out. Okay, so this would be dx over dt over time. Since this is going downward, and so let's just kind of do this right here. Okay, you would see right here, here's the ladder going further out this way, same distance, same length of ladder, right? Okay, this is y. All right, so this rate is decreasing if it's going down, right? At a rate of dy over dt. It's very possible that you could have something increasing at a rate of 3. I don't know, maybe feet per second, and this one's decreasing at a rate of maybe 4. And if it's going to be going down, we're going to have a negative at that feet per second, okay, like that. So basically that's it. So anyway, they're not generally going to be the same, and you think it would be, but it's not. So anyway, just be that as it may, that's the idea here with this problem that we just done. Okay, over here, excuse me. Alright, this one here, this is increasing. That's across. I don't know how this graph is. I don't know what it looks like, honestly, but the vertical is decreasing, okay, at this rate here. Okay, so you might want to put dy over dt equals -8, and you might want to put unit per second, okay, like that. Make sure that they see all of that. Okay, that's the idea behind it. This is KP, the MAFG. Sorry about the mistake, but hey, we all make them, but I'm trying to show you how to do this correctly, right? So this is done. This is good. This is the last of the 2023. I've looked at some 2024 problems, very good, and there's actually one just like this one. I can't remember the number of it, either 4, 5, or 6. I cannot remember which one it is, but boy, it's just exactly like this one. So just from 1 year ago, you get a similar problem. So that happens sometimes. It may not happen again this year in 2026. Who knows? I don't know what happened in 2025. I don't know what that looks like. I'm going to take a look at it though and see if there's any related rate free response problems there. But you get one of those every once in a while. Okay, not often, but every once in a while. And so anyway, KP the MAFG is about ready to sign off. If you will, hit that subscribe button. I've got hit that subscribe button and hit that like button. I always smile when I when I even saying hit the like button. If you'd like to make a comment, please make a comment. I appreciate that. And then this is not, again, hitting subscribe or hitting the like button. That's not about me, actually, really. If you don't do any of that, that's fine. Just hope you get something out of it. And my dog is barking for some odd reason. So we're going to sign off now. KP the MAFG signing off. Have a great day. My dog is probably barking at a butterfly. Okay.